Today we're going to talk about rational expressions. The first thing we're going to talk about with rational expressions is how to simplify them. So we want to make sure that we have everything factored out in the numerator and denominator and then cancel common factors. So really the object of the game is to factor and cancel as much as you can. All right, let's take a look at this little note over here. When you have addition and the order is exactly the same on the top and the bottom, the binomials will reduce to a positive 1. Now when you switch the order for addition for each binomial, it's still going to be a positive 1 because addition is commutative. Like 7 plus 6 is the same thing as 6 plus 7. All right, let's see what happens with subtraction. In subtraction, if the top and bottom are exactly the same and the order is the same, it does reduce to a positive 1. But this is new right here. When you have subtraction and the order is not the same, but the binomials have the same terms, what it reduces to now is a negative 1. That's going to be really important to memorize because that's something you're probably going to use throughout the year. All right, now that being said, let's go on to example number 1. Remember, the object of the game is to factor and cancel as much as you possibly can. So if I take a look at number 1, I'm going to do two binomials on the top because I know it's dots. It's an x plus 5, x minus 5. I'm going to do a GCF of an x on the bottom, or the denominator, and get x times x minus 5. I'm going to cancel now the x minus 5 for the x minus 5. I have nothing else to cancel, so my answer is going to be an x plus 5 over x. Now some of you may be wondering why you can't cancel the x's. The reason you can't cancel the x's is because the x on the top goes with the 5. It's a binomial. That x plus 5 is a term, and the x on the bottom is a term by itself. You can only cancel like terms, and they're not like terms, so you can't cancel the x's. Okay, with that being said, let's move to number 2. Object of the game, again, is to factor and cancel as much as I can. On the top, I can GCF out of 6 and get 4 minus x. On the bottom, I can't GCF, but I can go to two binomials. Let's see here. Factors of 12, that'll give me a negative 7, minus 3, minus 4. Can I cancel anything? Ooh, I can cancel a 4 minus x for an x minus 4. That's that new note up top that we talked about. When I cancel subtraction in opposite order, as long as they have like terms in there, I get a negative 1. I can't cancel anything else, so let's see what I end up with. 6 times a negative 1 is a negative 6, and x minus 3 on the bottom. Remember, you can't reduce the negative 6 and the negative 3 because they're not like terms. The x minus 3 go together. Okay, now with that being done, let's move on to another example. Number 3, it looks like they already GCF'd out for me, so I'm going to bring over the x squared and then go to two binomials on the top and end up with an x and an x, factors of a negative 14. That'll give me a negative 5 plus 2 and a minus 7. On the bottom, it looks like they GCF'd out for me a 4x, which was nice of them. I can go to two binomials, an x and an x, factors of a positive 8. That'll give me a positive 6 plus 4 plus 2. Let's do some canceling. An x plus 2 for an x plus 2. Ooh, I have one x that stands alone because there's no addition or subtraction sign with them, and I have an x squared on the top that stands alone, so I can cancel 1x for 1x. So let's see what I have left over. On the top, I have x times x minus 7. On the bottom, I have 4 times x plus 4. Nothing else can cancel. That's my answer. Now, you may be saying to yourself, hey, can I go even further with that? Can I do distributive property? Well, you can. You could actually leave your answer as x squared minus 7x over 4x plus 16. But it is not necessary. The original answer we came up with is sufficient. But please remember, if you decide to go one more step further, if you make a mistake doing it, you're going to lose points. So be very careful. We've done simplifying. Let's go to multiplication. When we multiply, the object of the game is to factor and cancel as much as you can, just like it was for simplifying. But now we can cancel up and down and diagonally. All right, so if I take a look at number 4, I have no addition and subtraction sign, so I don't have any binomials or or trinomial, so I can't do any GCF or 2 binomial. So I'm just going to prime factorize it out. It's just going to help me to see truly what I can cancel. So 6 to prime it out would be 2 times 3 times the C. On the bottom, 5 is prime, so it's 5 times D. Please remember, a prime number is a number that's divisible by 1 in itself. 15 would be 3 times 5. I have times C, and then there's 2D, so it's a D times a D. All right, 8, 2 times 4, 2's prime. 4 would be 2 times 2 times A. Okay, let's do some canceling. A 2 for a 2, a 5 for a 5, a D for a D, and that's it. That's all I can cancel. So let's see what I have left over. On the top I have 3 times 3, which is 9, C times C, which is C squared, and a D. On the bottom I have 2 times 2, which is 4, times A, which is 4A. So there's my answer. Now you may be wondering why I just didn't cancel right within the problem. Now you can do that, but some people sometimes get a little confused with all the exponents. So if you did it by actually reducing within the problem, for example, I could say 5 goes into 5 once and into 15 3 times, and didn't end up with the answer that I got, you might want to take the time out to actually prime factorize it out. All right, I'm going to tell you that I'm going to skip number 5 for now, and if I have time, we'll go back to it. And if we don't go back to it, that is one I want you to go back on your own to, and then we'll go over it in class. Let's go on to another example. I like number 6 because it's a word problem. So if the length of a rectangle is 3x plus 3 over 4x squared minus 4, and the width of the rectangle is 8x minus 8 over 6, express the area of a rectangle in simplest form. Okay, let's talk about what it is to find the area of a rectangle. Area of a rectangle is nothing more than take the length and multiply it by the width. All right, so I have A equals, my length is 3x plus 3 over 4x squared minus 4 times my width is 8x minus 8 over 6. So right now I'm multiplying rational expressions. So the object of the game is to factor and cancel as much as I possibly can. So the very first numerator I can GCF out of 3 and get an x plus 1. On the bottom it looks like I can GCF out of 4 and then get an x squared minus 1. Hey, but isn't x squared minus 1 dots? So I can even go further to x plus 1 times x minus 1. So now I'll scribble out this piece because I was able to factor it even more. All right, I'll GCF out an 8 and get x minus 1. And then 6 I'll do 2 times 3. Okay, let's see what I have left here with number 6. I can cancel out a 3 and a 3. 4 goes into 8 twice. Ooh, then I can go a 2 and a 2. I'm on a roll. An x plus 1 for an x plus 1. And an x minus 1 for an x minus 1. Everything on the top canceled and everything on the bottom canceled. When the whole entire fraction cancels out, your answer is 1. So the area for this rectangle will be 1. Okay, so let's go on to another. Now we're going to learn how to divide. Dividing is just like multiplication, but you first have to change the division symbol to multiplication and flip or take the reciprocal of the second fraction. And then again, it's factor and cancel as much as you can. Take a minute, pause the video, write the steps, copy number 7, and when you're done, come back and we'll do it together. Okay, now that you have everything copied, let's go ahead and divide number 7. I'm going to change it to multiplication, so I'm going to rewrite it as 18 xy cubed over 7a squared b squared times 35a squared b over 12x squared y. Okay, so now I'm ready to factor and cancel. I have no addition and subtraction sign, so I can't do GCF for 2 binomials. So I'm going to prime it out because it's easier for me. If you want to reduce within, that's fine too. So 18 is going to be 9 times 2. 2 is prime, so 3 times 3 for 9, times an x times 3 y's. 7 is prime, times an a times an a, times a b times a b. 35 would be 7 times 5, both of those are prime, times an a times an a, times a b. 12 would be 2 times 6, 2 is prime, 6 would be 2 times 3, times an x times an x times a y. All right, let's get ready to actually cancel. A 2 for a 2, a 3 for a 3, a 7 for a 7, an x for an x, a y for a y, an a for an a for an a b for a b. Doesn't look like I can cancel anything else out. So let's see what I have here. On the top I have 3 times 5, which is 15. And I have y times y, which is y squared. On the bottom I have b times 2 times x, so it'll be 2bx. And there's my answer. All right, let's take a look at another example. With number 8, it's a division problem. So we're basically going to rewrite it as a multiplication problem and then factor and cancel as much as we can. So we have x squared minus 16 over 12y plus 36 times y squared minus 3y minus 18 over x squared minus 12x plus 32. Okay, the object of the game is to factor and cancel as much as I can. So this is dots, x plus 4, x minus 4. GCF of a 12 and get y plus 3. 2 binomials and get y minus 6, y plus 3. Down here, 2 binomials and get x minus 8 and x minus 4. Okay, let's do some canceling. Here we go. X minus 4 for an x minus 4. An x plus 3 for an x plus 3. Not a lot canceled. Did I make a mistake? Nope, I didn't. So let's see what I have left over. On the top I have x plus 4 times y minus 6. And on the bottom I have 12 times x minus 8. And there's my answer. Okay, let's go. Looking at number 9, if x squared minus 49 over 2x plus 6 represents the area now of the rectangle, and x plus 7 over x plus 3 represents the measure of its length, then find the rational expression that represents the width. Okay, pause the video, take a minute, write the question. All right, now that you have the question written, let's set it up. So again, it's area of a rectangle, which is a equals length times width. All right, x squared minus 49 over 2x plus 6 is the area. So x squared minus 49 over 2x plus 6 equals, the length is x plus 7 over x plus 3 times the width, which we don't know, so we'll leave it as w. I've got to get w, or the width, by itself. So I'm going to divide each side by x plus 7 over x plus 3. Multiplication and division on the right side cancel each other out, so I do end up with w by itself. But on the left I have division, and it looks really weird like that. I can either do LCD for a complex fraction, or I can write it this way. I can say x squared minus 49 over 2x plus 6 divided by x plus 7 over x plus 3. Now I'm dividing rational expressions like I'm used to. All right, I want you to finish this one on your own. And when you're done with this, go back and finish the other one we didn't do. And then tomorrow in class, we'll check your answers, how well you did on both of those. Have a good evening.